In July 2001, in subantarctic waters, 4 helicopters carrying 120 tons of toxic bait hovered above a steep island, where the wind never stopped howling. Beneath the cliffs, a population of approximately 200,000 Norway rats was breeding across 11,000 hectares of land, creating an unusually high population density. They had severely damaged the ecosystem by consuming seeds, threatening young birds, and diving into the sea to catch mussels, causing serious declines among many native species. New Zealand's plan was clear: spread toxic bait across every square meter of land, all the way to the final rocky ledge. If even one pregnant female rat survived, the entire operation would return to the starting point. However, this approach carried a major risk. The rodenticide could also harm the rare bird species already struggling to survive on the island. To solve this complex ecological problem, scientists had to design a highly precise campaign capable of completely eliminating the invasive rodents while still protecting the last surviving native creatures. When scientists released the highest resolution satellite maps ever produced of the Southern Ocean, Campbell Island appeared as a tiny green dot, completely isolated within the band of ocean known as the Furious 50s. But to understand the importance of this green dot, we must travel back into the past. After millions of years of complete isolation, the island had become a biological fortress with no land mammals, where the normal rules of evolution had been overturned. Plants did not grow tall to compete for sunlight, but instead spread close to the ground to withstand storms with winds reaching 100 kilometers per hour. Giant flowering herbs produced spectacular blooms and leaves nearly 1 meter wide, while their roots clung firmly to the waterlogged peat. With no natural predators, the island's insects grew to enormous sizes and abandoned the ability to fly. Wetter insects as large as a human hand crawled slowly across the ground. Seabirds and landbirds followed the same pattern. With no enemies waiting to attack them, they did not need to build nests on inaccessible cliffs and could calmly lay their eggs directly on the ground among the dense grasses. Everything began to change when the ship Perseverance arrived in 1810. The first visit removed only marine resources, but the real crisis began in October 1828, when the Perseverance itself sank inside one of the island's deep bays, allowing uninvited passengers to swim ashore from the Færn Oration 45. Wreckage: Norway rats. The rats needed only 12 years to spread across all 11,000 hectares. From only a few original individuals, they exploded into an army of 200,000 during favorable breeding seasons. Landbirds became the first victims. Pipits, snipe, and the Campbell Island teal, a small, flightless duck, disappeared completely from the main island. The rats also invaded the burrows of small seabirds, preying on their eggs and chicks. When those food sources declined, they turned toward the island's smallest organisms by consuming beetles, devouring the seeds of giant plants, and even developing the behavior of diving into shallow water to catch mussels. The destruction did not end there, because during the late 19th century, humans brought 7,000 sheep and populations of feral cats to establish farms. Vegetation was stripped away and the soil was torn apart, transforming Campbell Island into a barren landscape. By 1931, the farm had been abandoned, while the sheep and cats gradually disappeared naturally or were removed by humans. But the 200,000 rats remained firmly established as the island's dominant species, and their population continued breeding until 2001, when conservationists decided to launch a historic intervention campaign. Eliminating rats from a vast mountainous island with one of the harshest climates on Earth had once been considered impossible by scientists. The only intervention tool available was Brodifacoum, also known as Pestoff 20R, a second-generation anticoagulant rodenticide. This active ingredient was extremely effective, requiring only a single dose. However, Brodifacoum presented one major obstacle because it was not selective and could affect Norway rats as well as native gulls and teals. In 2001, the campaign was activated. The central strategy of the project was to use nature's own biological behavior to protect nature. The baiting operation was scheduled for the middle of the harshest winter. With temperatures approaching freezing and storms battering the island, most seabirds had already flown out to sea to escape the cold, reducing the presence of non-target species on the island to its lowest possible level. The bait pellets themselves were then dyed a distinctive shade of green. Studies of bird vision indicated that this color attracted little attention from birds, while rats, which have poor eyesight but an extremely sensitive sense of smell, remained drawn to the grain-based scent inside. 4 helicopters began taking off. Unlike the modern AI-guided autonomous drone technology, available in 2026, pilots in 2001 had to rely on exceptional manual flying skills combined with the relatively basic GPS systems available at the time. Technician Brian Beck received the most difficult assignment, repeatedly flying along the coastal cliffs only 15 to 20 meters from the vertical rock walls, so the pellets could land on every ledge and inside the deepest cracks where the final rats might be hiding. Every flight path was redrawn on a satellite map. Each evening, the entire team concentrated on analyzing the recorded flight data. If the system showed that even a strip of land, only a few square meters wide, had been missed because of strong winds, a helicopter had to return to those exact coordinates the following morning. They had 1 month to distribute all 120 tons, and they completed the mission. No accidents occurred, and not a single southern Royal Albatross collided with the helicopter blades because the pilots deliberately reduced their speed. Silence settled over the island, the compound had reached every corner, and the research team entered the period of waiting for the results. In rodent population biology, any individuals that survive an intervention will immediately retreat into hiding. Searching for 1 or 2 rats across 11,000 hectares of mountainous terrain exceeds ordinary human capabilities. The only way to determine whether the campaign had succeeded was to allow time to pass. The team had to wait through 2 breeding seasons, because any surviving rats would multiply into a population large enough to detect. In 2003, 6 conservation officers returned to the island. This time, they carried no chemicals but brought Jack a working dog specially trained to respond to the scent of rodents. For an entire month, they searched every trail and every remaining section of the old buildings. More than 4,000 traps were installed. Highly attractive wooden blocks, soaked in peanut oil, were secured to the ground along the rats' familiar travel routes. If even 1 rat remained, the smell of peanut oil would draw it out and leave tooth marks in the wood. During the survey, however, the research team discovered an alarming sign rat droppings inside the abandoned weather station buildings. The atmosphere became tense, because if the droppings were fresh, then 120 tons of bait, 2 long years of waiting, and more than $2.5 million had all been wasted. Every hope of ecological recovery appeared to collapse. The samples were immediately collected, sealed, and sent directly to a mainland laboratory. No one was allowed to touch the traps around the area until the results arrived. However, the laboratory report produced an unexpected finding. Spectroscopic analysis detected no Brodifacoum, while the samples instead glowed with the color of rhodamine. Rhodamine is a harmless dye that had been used during a non-toxic bait trial in 1999 to test how widely the pellets would spread. This meant that the rat droppings were almost 4 years old. Because of the freezing preservation conditions of the sub-Antarctic climate, they had not decomposed and still appeared as fresh as if they had been deposited the previous day. Throughout the entire month on the island, Jack did not bark even once. The peanut oil blocks remained untouched, and all 4,000 traps remained empty. Campbell Island officially became the largest island in the world at that time to successfully eliminate an entire invasive rat population. The rodents had disappeared permanently, and vegetation began growing again. However, anyone who believes nature can recover immediately once an enemy is removed is overlooking a far more complicated reality. Successfully eliminating 200,000 rats marked a historic turning point. But removing a harmful force from an ecosystem does not mean the environment will recover immediately. This is the detail that most conservation stories often ignore to make their outcomes appear more perfect. When scientists turned their attention toward the bird species that needed to be brought home, they encountered a biological limitation that seemed almost impossible to overcome: the genetic bottleneck effect. The Campbell Island teal, the flightless bird that became a symbol of the island, did not disappear completely during the 19th century. A very small number of them managed to survive on Dent Island, a rocky outcrop rising from the ocean 3 kilometers from the main island. For more than 100 years, approximately 50 ducks clung to life on that barren rock, drinking collected rainwater and feeding on moss. When humans captured 11 individuals and transported them to a mainland breeding center in 1984, many years passed without a single egg successfully hatching. No one understood what conditions this mysterious nocturnal duck required in order to reproduce. It was not until 1994 that a female named Daisy and a male named Donald finally formed a pair and produced 2 ducklings. But the truth was that among all the wild females brought into captivity, Daisy was the only one capable of reproducing. This meant that the entire captive Campbell Island teal population, being prepared for release, shared the same bloodline. They were all descendants of a single mother. This severe lack of genetic diversity made the population exceptionally vulnerable to any environmental change or newly emerging pathogen. They might survive the rats, but even a simple virus could threaten the entire species within only a few weeks. Furthermore, as the world entered the 2020s, the latest data exposed an even greater threat. Islands can be protected through biosecurity measures, but they have no walls capable of stopping changes in the ocean. Remote sensing data from 2026 showed that the waters surrounding Campbell Island were experiencing repeated marine heatwaves. Seabirds that depend on the ocean, including grey-headed albatrosses and yellow-eyed penguin species that should have experienced population explosions after the rats disappeared, were instead struggling with starvation. Chicks were failing to survive in their nests, not because predators were eating them, but because their parents spent too long searching for food and could not return in time. Humans can clear the land, but they cannot control the ocean. The island's recovery is being trapped between a genetically depleted population and an ocean experiencing abnormal temperature increases. Everything appeared to have reached a dead end. Yet in places where human intervention reaches its limits, nature sometimes produces recoveries beyond anything we can imagine. While scientists were still carefully calculating the release schedule for each individual mapping genetic lineages and worrying about survival rates, an invisible chain reaction had already activated itself. Nature did not wait for official reports, but quietly began acting immediately. The recovery began at the bottom of the food chain quietly and almost invisibly. Only a few months after the rats disappeared, rustling sounds began emerging beneath the thick layer of fallen leaves surrounding the old observation stations. Giant, wetter, wingless insects, once believed to have been wiped out, suddenly appeared everywhere. A slight shake of a low branch was enough to make them fall to the ground. They had patiently hidden deep beneath the mud for an entire century, and now they were rising to reclaim the land. But the greatest surprise did not occur beneath the leaves. It came from the sky, where one creature accomplished something no one had believed possible. 1 kilometer south of Campbell Island stands Jacquemart Island, an enormous basalt pillar rising vertically from the stormy sea. There, a bird that had never previously been classified by humans, the Campbell Island snipe, had survived for 170 years. Biologists had insisted that this tiny bird with its weak wings could never cross 1,000 meters of wind-battered ocean to return to the main island. Humans would have to bring them back through capture, captive care, and gradual environmental acclimation, a process that could require as many as 20 years. But humans had underestimated the instinct to survive. In 2003, only 2 years after the baiting campaign ended, small footprints were discovered in the mud along Campbell Island's shoreline. In 2005, a young snipe was found. By 2006, more than 20 adults and several active nests had been recorded. No incubator was opened and no helicopter was deployed. Guided by some powerful instinct, the snipes beat their fragile wings, threw themselves into the violent winds of the furious 50s, and crossed the ocean gorge to return to their ancestral land. From a population confined to a 19-hectare rocky outcrop, they spread naturally across the entire 11,000-hectare island. The bird was later given the scientific name Coenocorypha aucklandica, perseverance, meaning perseverance. Following their return, Campbell Island teals, carrying Daisy's bloodline, were also transported back by helicopter. No care centre was waiting to receive them. From the first 50 released individuals, they disappeared into the darkness, found their own food, and reproduced independently. No one knows exactly how many Campbell Island teals now live on the island, because they are exceptionally skilled at hiding. But biological estimates indicate that a population once believed extinct has now surpassed several thousand individuals. The food web reconnected itself, and the island regained ecological balance. The vast island is now completely free of invasive predators. The sounds of rats have been replaced by the clicking of wetter insects and the calls of pipits gathering together. Everything appears to have returned to its original natural order. However, behind the success of this conservation model, scientists and environmentalists remain divided. The Campbell Island campaign was once at the center of a fierce controversy. Many experts strongly opposed the distribution of the bait, criticizing it as a high-risk environmental intervention. They raised a profound ethical question: should humans use such a large quantity of chemicals to interfere with an ecosystem? The risk to vulnerable native bird species was real. In addition, the project consumed millions of dollars in public funding, leading many people to question its opportunity cost. Some argued that instead of using chemicals, nature should be allowed to adjust through its own harsh process of adaptation. After all, if only one female rat survived, the entire campaign would fail, and any native birds harmed by the operation would have died for nothing. Despite those pressures and doubts, the project succeeded. Campbell Island's success did not remain an isolated exception. The scale of what occurred there became a global turning point and provided powerful scientific evidence that the boundaries of what seemed impossible could be broken. By 2026, the campaign had become a model for one of the most ambitious visions in conservation history, the Predator Free 2050 strategy. New Zealand established the goal of completely eliminating invasive rats, stoats, and possums from the entire country by 2050. Artificial intelligence bait systems, heat-sensitive traps, and unmanned aircraft developed during the 2020s all trace their foundations back to the manually guided flights along Campbell Island's cliffs in 2001. These efforts demonstrate that humans may cause ecological collapse, but they also possess the technical ability and determination to reverse it. Yet as the Campbell Island case draws to a close, a deeper truth emerges, reminding humanity of the limits of managing nature. We achieved a technical breakthrough. We used a chemical intervention to restore the environment. But the recovery did not come from laboratories or multi-million-dollar plans. It came from the powerful survival instinct accumulated over millions of years within every giant plant root, within the fragile wings of a snipe crossing a stormy sea, and within the nocturnal teal's determination to preserve its bloodline. The real question is not whether humans can repair a damaged ecosystem. In a world where oceans grow warmer every day, climate patterns become increasingly unpredictable, and genetic limits remain dangerously fragile. How long can the resilience of these species protect them once continuous human support disappears? The struggle to protect nature has never been easy, and sometimes the greatest decisions carry unpredictable risks. If you found these ecological conservation efforts fascinating, press the subscribe button, like and share the video, and join us as we continue uncovering the mysteries of the natural world in future episodes.